Okay, this is a review of the first part of Chapter 9. Because Chapter 9 test is coming up here in a few days, and I want to cover the stuff that we haven't really talked about in a long time. What if you had this? This is a super simple one, and just to kind of try to remind you what this is like. What on earth does that mean? First of all, somebody just tell me, what is that? It's saying to do something. Yes. Find the sum of the first three terms. And then how do you find the first term? Say it. Stick one in. So one goes there. So this is 2 minus 1 is 1. And then I'm going to put in another one. Put in a 2 now, because we're marching from 1 to 3. So now we're going to put in a 2. Put in a 2. 4 minus 1, 3. And are you noticing it looks kind of like it might just be the odd numbers? 1, 3. And then if I put in a 3, 2 times 3 is 6, minus 1 is 5. Look at that. It is the odd numbers, except it's the first three odd numbers. And then what I wrote is technically not right. It's the first three terms. But what this is summation thing is asking us to do is actually add them, and final answer, 8 plus 1 is 9. Raise your hand if you understood that one. Okay, good. So that's what that little summation thing means. And I just did an arithmetic one, right? All right, so what if I had gone the other way? What if I'd have said, here's my three terms, 6, 8, 10, dot, 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 and it would have gone forever, except I only want the first three terms. Can you write me the sigma for this? What would this be in sigma notation if I really only want the first three terms all added up? I'll pause for a second while you give that one a try. Okay, if you're not done yet, it probably means you really didn't know how to do it efficiently. You can kind of guess and check your way to these, but that's not the way to go. You want to use one of those formulas. A sub n, that's not the kind where you add them up. That would be an S sub n. And this is just saying any term in a, well, it can be arithmetic or geometric. In this case, what did I do? Arithmetic. And so if I'm going to do any term in an arithmetic, you have the starting term, which sometimes I called A sub 0. Now I'm just calling it A, because that's what you're going to see on your finals sheet. The final, you're going to get a, I shouldn't say that. Yeah, on the finals, you get a copy of this too. But for your Chapter 9 test, it's got this formula sheet. So you wouldn't have to have this memorized. Plus D times n minus 1. And I drop that here. A plus D n minus 1. But then I got to plug in what I know. I know the starting, which is what? 6. And then I know the D, which is what? Because of this minus this. There we go. This, and if I only want the first three terms, I go from 1 to 3. Raise your hand if you wrote that properly. Okay, good. Okay, yes? Could you distribute it? Oh, yes, you could multiply this thing out. 6 plus 2n minus 2, and then put those together and say 2n plus 4. That means the same thing. That's fine. I'm just trying to show you that you don't have to do that. So, all right. Next, what if it had been geometric? Yes, question. Good question. She asked, is there any case where you would have to use something other than 1? Not if we let you write it. If we let you write it, you can start with 1. And that's probably the easiest way. Could you start with 0? Yeah, but then it'd be more complicated to make your little formula too. So, all right. So let's make one of these, except have it be geometric. Let's have it be geometric and increasing. Let's start with 4. And times it by 10 is 40. And then times it by 10 is 400. And I'd like you to tell me what would be the sigma for that if I wanted the first infinity terms. All right, you should have said from 1 to infinity. And then since this is geometric, I got to use the other formula, which I hope you know, is r to the n minus 1. And then what else would I need in there to tell it the rest of the info? The starting. So a times r to the n minus 1. So that's a times r to the n minus 1. And now I'm going to stick in what I know. I know the start, which is 4. I know the r, which is always just that divided by that. 40 divided by 4 is 10. And therefore, this is 4 times 10 to the n minus 1. And you can check if you did it right by just sticking in a 1 and seeing if it actually generates that first term. If you want to be extra careful, stick in a 2, see if it generates the next term. And this would. Okay, so now, what is the actual answer to this sigma that you wrote? Yes, sir. There is no answer. Because, why? Yeah, it just keeps going up. And you're going to try to do an infinite number of these being added together. And I would not call the answer infinity. I would say that there is no answer. Because if you say the answer is infinity, you're saying that there is an answer. Okay. How about if it's going down, though? That kind you can actually add up infinite ones. So let's say it starts at 3, and then it goes to 1/3, and then it goes ... And I'm telling you it's a geo, so we know it didn't subtract 2 2/3. It's a geometric kind. I'd like you to write for me the sigma for this, and then actually figure it out. Write it in sigma notation. And then there is a formula, and I know there'll be a formula sheet, but can anybody tell me that formula for an infinite? It's a pretty easy one. What? Over what? Only 2 people remember? Really? Okay. That's probably as soon as you knew you didn't have to memorize it, you just didn't. Okay. What you got? A over 1. You are right. A over 1 minus r. Okay, use that formula if you want to actually do the summation. I'll pause for a second while you give that a try. Okay, here's how it should have gone. Well, first of all, this is an infinite series, and therefore this is 1 to infinity. And this would be the formula generally, which is a times r to the n minus 1. And then I stick in what I know. I start with a 3, and my r is 1/3 divided by 3. That divided by that. And if you think of that as 1/3 times 1/3, that was 1/9. Raise your hand if you knew the r was 1/9. Okay, good. Next up is I'm going to figure out the actual answer over here by sticking in a, which is 3 over 1 minus 1/9, because that's what the r was. And that's just taking this formula and following it. And that means 3 over 8/9, which means 3, instead of divided by, times 9/8, put it over 1, which is 27/8, which is, it's okay to leave it as 27/8. First of all, raise your hand if you had 27/8. Okay, good. That's infinite series. Now, how can they get more complicated? What if they give you only a couple numbers of a series? Let's say they don't give you the first one, they don't give you the second one, and they give you the third one. And the third one in the series, I'm going to kind of take the card away and reveal it. And let's say that the third one in the series is 8. And it was geometric. Is that enough to know what this formula had to be? No. Because if I was timesing by, what if I told you I was timesing by 100? I could go back and make up numbers for this and this, couldn't I? That are based on timesing by 100. Or what if I told you I was timesing by 2? You could go back and make numbers. So I'd need to either know what 2 things. There's 2 things I could tell you to finish this question. Yes. The common ratio. Yep. Or I could tell you what? Yes. another number in this series. So what if we made it, the easiest thing is if I tell you the first number, then it's going to be really, really easy. Okay, let's just do one like that. So let's say that it does start with 2. Now, I know you might be able to do this in your head. In fact, I'm going to change it because that'd be too easy. I'm going to make it 1. Okay, it starts with 1. Now, figure out everything. Obviously, you can't find its sum to infinity because it's going up. But what you could do is, let's say that there's 10 numbers in this sequence. You could find the sum of the first 10 numbers. All right, pause for a minute while you figure that one out. Okay, it has been requested that I give the formula for adding up the first 10 numbers. Well, I'm going to give you the general formula. The sum for an arithmetic is where you start with A, and then you add. This is the first number. This is the last number. Remember little Friedrich? He took the smallest number and then the biggest number. Okay, and this is the biggest number. And then, oh wait, this is for addition. Sorry. I got to do the one for, that would have been times n over 2. That's for adding up the ones when they're arithmetic. All right, for geometric, of course I need to know what it starts with, so I'll start with A. And then you can either do this as 1 minus or as minus 1. And this is r to the n over just r. I'll pause for a moment while you give that a shot. You're going to use that formula to add up those first 10 terms in this sequence. Okay, I need to get going on this one. So here's how I would have thought it through. There's a formula for this to find any term. And I'm going to say a sub n is equal to, that's the any term. For a geometric, it's the starting amount times r to the n minus 1. And then I know some stuff. I know the starting amount is 1. And r to the n minus 1, I don't know my r. That's a little frightening. But I do know my n for this case. My n is, this is the third term, comes out to 8. I stick in the third term, comes out to 8. And I go 8 equals 1 times, well, 1 times doesn't really do anything, r to the 3 minus 2, which is squared. So then r must equal the square root of 8. Now, this is important. Did you remember that when you do this, you're square rooting both sides, you have the absolute value of r, and therefore there is 2 r's that could have been. R could have been positive or negative. Think about it. If it had been multiplying by a negative, you'd have never known that there was a negative underneath there, would you? And then when it multiplies by a negative again, it would have gone back to positive. You'd have never known. So again, math works. If you do this, you're supposed to get absolute value of r, and you do, and that means that r has 2 answers, both positive square root of 8 and negative square root of 8. Raise your hand if you had that one right. And I'm going to say if you forgot the plus and minus, you know, you wouldn't have got full credit, but how many of you got it without the plus minus thing? Okay. All right, now once r is root 8, then that's all I need to know, because that goes here and here in your formula, and my starting values right there, and then my how many I want, 10, goes right here. So I totally get that on a test you would not have been able to get this final answer of square root of 8 to the 10th minus 1. I know you don't know what the square root of 8 to the 10th is. I don't either. I could say that this is 8 to the 1/2 to the 10th, which is the same as 8 to the 5th. Anyway, that one still, I don't know what 8 to the 5th is. It's huge. But okay, and then that's all over r, which is square root of 8 minus 1. And this is a 1 times because we started with a 1. But yes. Yep, then you'd have to have the one that has the negative r. Now, just for a, yeah, it would make a difference because this one's going to be put to the power of 10, which means the negative r isn't going to do anything. But on the bottom, that one isn't. So therefore, it would affect the answer. So you get 2 different answers. And it makes sense that they'd add up to different things. If one of them's got negative numbers in it, and the other one's only got positive numbers in it, of course, they're going to add up to different things. So, okay. So that was pretty intense. That's like, you know, I get that might have taken you some time to figure out. Okay, and that's all I want to talk about for that chapter for today. Tomorrow I will cover induction and binomial theorem to be able to do those expansions like 2x plus 5 to the power of 9 or whatever. We'll talk over those and also how to do an induction proof. All right, and that's all I have for that part of the video for today.